So this is kind of a problem that comes up quite often in infinite series. So they ask us to write a recurring decimal as a fraction. Okay, so we all know what a fraction is, so something like 1 over 2. But now we're going to look at what a recurring decimal is. So there are three kind of types of recurring decimal that we're going to come across really in these problems. So the first one will look something like this. Could be 0.3 with a dot over it. So that's a recurring decimal, and it means 0.33333, and that goes on forever. Okay, yeah, so it doesn't end. So that's what a recurring decimal means. It means a decimal that repeats and goes on forever. So we can have a 1-digit, say, recurring decimal, I'm going to call it. Or else we could have a 2-digit recurring decimal. So this would be 0.72, and there'd be a dot over each of these, okay? So in this case, it's going to be 0.727272, and that's going to repeat forever. So it's going to repeat in that fashion. So if it's 7 dot and then 2 dot, it's going to keep going like that. And then the third type we're probably going to see will be something like this, 0.142, and there'll be a dot over the 2 and there'll be a dot over the 1, but there won't be a dot on the one in the middle, and that's going to mean 0.142, 142, 142, and then it keeps continuing like that. Okay, so you can have as many numbers as you want in between here. You could have 10 numbers in between and just a dot on one side and a dot on the end, and then it'd mean that pattern would repeat. You'd write the one on one side, the 10 numbers in the middle, the dot on the other side, and then you'd start doing it again. You'd keep repeating like that. So that's what a recurring decimal means. So how do we write these things as fractions? That's what we're going to learn now in this video. So there's a method to it. So we're going to look at this middle example, because the other examples will all follow the same sort of style anyway. So we're going to look at the middle example, and we have this one here. So we're going to say just write 0.72 recurring decimal as a fraction. So how are we going to do this? The first step we're going to do is we're going to write 0.72 like this is equal to 0.727272 and so on. Okay, another way of writing that would be 0.72 plus 0.0072 plus 0.00072 plus, I'm going to keep going. So if you kept doing that, you get the same number as you have here, because you can see that 0.72, 0.0072, that's going to be this 72 here. Then 0.000072 will be this 72 there, and I can keep going on like that. So now we're actually going to write it in one more different way. So I'm going to write it like this. So 0.72, if we write that as a fraction, that's going to be 72 over 100, plus if we write this as a fraction, it's going to be 72 over 10,000, and this is going to be 72 over 1,000,000. And this is going to continue on, okay? So there are two main ways of finding out which fraction it is. You can either count how many spaces are after the decimal place. So in this case, there's 7 and then 2, so that's 2 spaces. So that means on the bottom you're going to have 100 because there's 2 zeros in 100. And this one here, if you move the decimal space, it's going to be 1, 2, 3, 4 spaces. So there are 4 numbers after the decimal place. That means there are going to be 4 zeros in the bottom. Here there are 1, 2, 3, 4, 5, 6 spaces, or six things after the decimal place. That means there are going to be 6 zeros, so it's 1,000,000. So you can either do that, or else you can just do a little bit of trial and error in your calculator and write those in. Yeah, so you'd have to do a bit of trial and error with the calculator and try to figure out which one of these fractions is equal to that decimal. So once we have this looks a lot like a geometric series that we've seen before. Okay, so I'll scroll down here and we'll start looking at it as a geometric series. So the first term in this geometric series we see here is 72 over 100. So A is equal to 72 over 100. So now what is OR? What's the common ratio between them? So you can either spot that you get an extra 2 zeros each time. Yeah, so that means OR is going to be equal to 1 over 100, because if you multiply something by 1 over 100, you get 2 extra zeros in the bottom. Or if you're not so sure about that method, you can always remember that T of 2 divided by T of 1 is equal to OR. So if you write, say, 72 over 10,000 and divide that by 72 over 100, pop that into the calculator and you'll get 1 over 100 either. So either of those methods work fine. Okay, so now that we have A, we have OR, we can find this. Remember, this is an infinite series that goes on and on forever. So we can use the infinite series, the limit equation. So I'm going to do that in bright blue. So I'm going to write it here. It's going to be S of infinity is equal to A divided by 1 minus OR. And we can use that because OR is less than 1. So that means S of infinity is going to be A, which is 72 over 100. 72 over 100. All divided by, let me scroll down a little bit more, 1 minus OR, so that's going to be 1 minus 1 over 100. Pop that into your calculator and it'll be S of infinity is equal to 72 over 99. And you can always check that as well, so if you put 72 over 99 into your calculator, you'll find that it's equal to 0.727272 and so on, so that just keeps going forever. So that's a quick way how to write recurring decimals as fractions. Make sure you're comfortable with this because they do ask it quite a lot. It's really similar if you look at one like this. I'll just do it really quickly in, I'll say, purple here. Your fractions are going to be, say, 3 over 10 plus 3 over 100 this time plus 3 over 1,000. So the numbers in the bottom are going to go up a little bit slower than 100, 1,000, a million, okay? And then the same if we do it down here, it's going to be 142 over 1,000 is going to be the first one, and then the second one is going to be 142 over 1,000,000. So in this case the numbers go up a lot quicker, but the same general method is still the exact same. Okay, so yeah, that's all we really have to look at for turning a recurring decimal into a fraction. Try a few yourselves, and yeah, that's all there is to it. So we'll see you next time. We're going to do another problem with Actually, we're going to look at sigma notation in the next video. So a lot of people have a lot of trouble with sigma notation. Sigma notation is just this letter there. So you might have seen that. You might find it a bit confusing. We're going to clear that all up for you in the next video. So we'll see you then.